Good day, grade 9s. I'm Miss Todd, and today's lesson will be about forces. We are going to look at what a force is and what the different types of forces are that exist on Earth. Let's start with what is a force. A force can be defined as a push or pull or twisting action done on an object. A force is also classified as the power that is used or produced when something is moved, and we actually use forces in our everyday lives, like picking up food or opening a door. For forces, the symbol that we use to represent a force is a capital F. When we measure forces, we use newtons, which is known as its SI unit. And the SI unit of newtons was named after Sir Isaac Newton. So how it came about: so Isaac Newton discovered gravity when he saw an apple falling from a tree. Then he realized that there must have been some type of force that's acting on a falling object, like an apple, otherwise they would not have moved. So our SI unit, or our measuring unit for forces, is newtons, and it's named after Sir Isaac Newton. The way in which we represent forces is with the use of arrows. So arrows will represent the magnitude, which is the strength, as well as the direction of forces. Now, the reason we do this is because forces are known as vectors, as they have both magnitude and direction. So the diagram given to you here shows the direction in which the force is applied. So that's the arrow. And the length of the arrow or the line will represent the magnitude or the amount or the size of the force that is applied. To represent force diagrams, we use a diagram that's used to show the direction and relative magnitude of the force. So here again, we are using arrows, which represent the magnitude, and the direction will be based on the positioning of an arrow. So when we draw a force diagram, there are four important forces which you must know. The first one is normal force, and this is the force that's exerted by the surface onto an object. We then have gravitational force, which is the attraction between the mass and Earth, or the mass and the ground. We have pulling towards the end of the object, the back of the object, there will be friction, which resists the motion of the object on the surface in which the object is moving. And lastly, we have applied force. And applied force is then applied to the object, either by someone pushing or by another object. What's important to remember with forces is that they always exist in pairs. So the force that is exerted between two objects on each other, they always act in a pair. So if we have a look at this example between our action and a reaction, or over here with the ball, we have an action and a reaction. That is the pair that that forces are exerted. This allows us to then distinguish between balanced and unbalanced forces. So if a force is balanced, it's based on the pairs that are pairs of forces that are acting on the object. So if we have a look at balanced forces is when there are two forces that are acting on an object in equal size, so it's the same magnitude, but in an opposite direction. This then means there will be no effect that occurs because the forces in pairs that are acting on an object are the same magnitude, but in opposite directions. Now, with unbalanced forces is when there is different magnitudes of the forces that are exerted in opposite directions. So this is when one force in an object is larger than the other force of the object. This means an effect occurs, which shows it is unbalanced. So movement could occur, or there could be a change in shape of the object, or anything along those lines, which we will now discuss. So forces can have the following effects on an object. It can either set an object in motion, which means it moves the object, or it could change the speed of an object, or it could change the direction in which the object is moving. So if we have a look at this little diagram, you can see that the force will change the speed, the motion, and the direction in which the object is moving. Forces can also change the shape of an object, and it has the ability to rotate an object. All of these will occur if a force is applied to an object. Let's have a look at the different types of forces. So our first type of force we are going to look at is contact forces, and these are forces that occur between objects that touch each other. Our first example of a contact force is friction. Friction occurs when two surfaces move over one another. Tension is our second contact force, and tension occurs through a pulling action, or when something is pulled, it's considered a contact force known as tension. Our third contact force is compression, and compression will occur due to a pushing action. So these are all contact forces, and it's the forces that occur between objects that are physically touching each other. We have a second type of force here, which is field forces, or it can be called non-contact forces. These two terms are used interchangeably, so you should know both what a field force is and a non-contact force. It is the same concept here. So these are forces that occur between objects over a distance. Our first force is gravitational force. Our second one is magnetic force. And our third one is electrostatic forces. So these three specific types of non-contact or field forces we'll be going into detail with in this next section coming up. Let's start with gravitational forces. So gravitational forces, they are the attractive forces that objects exert on one another over a distance due to their masses. So we consider it being the attractive pull between two objects, and it is due to their masses. So gravitational forces in our solar system, we have the sun and the planets that exert a gravitational force onto one another, and this ensures that it keeps them in their orbitals. What's important to remember about gravitational forces is that the greater the mass of the object, the stronger the gravitational force attraction is between them, and the closer the objects are to each other, the stronger the gravitational force is between them. Now we look at the difference between weight and mass. So let's start with mass. Mass is the amount of matter that is found in an object, and it is measured in kilograms. Weight, however, is the gravitational force of an object that is exerted by Earth, and weight is measured in newtons. So the mass of an object will always remain the same no matter where it is measured, but weight of an object changes depending on where it is measured. So many people will use the term weight incorrectly in our everyday lives. We usually say my weight is X amount, where it should technically be my mass is X amount. Let's have a look at an example of weight. So the changes in weight will depend on the mass of the object, the gravitational acceleration, and the distance between the objects. An example I've included here is about astronauts. On Earth, an astronaut's mass will be 120 kilograms, and the weight on Earth of this astronaut will be 1,200 newtons. But on the moon, the mass still remains the same of the astronaut, which is 120 kilograms, and the weight will change to 200 newtons. This is because the weight on the moon is smaller. So Fg on the moon is smaller as gravitational acceleration is smaller. This is due to the moon being much smaller than Earth. Now we are going to start with calculating weight. So the formula for calculating weight or gravitational force is the mass of the object times gravitational acceleration. The formula that we use is Fg is equals to m times g. Fg represents gravitational force, and the unit in which we measure it is newtons. Mass is the small letter m from our formula, and the unit that we measure mass in is kilograms. And gravitational acceleration is the small letter g from our formula, and it is a constant value of 9.8 meters per second. Let's do some examples of how to calculate weight. This first example we have, the car has a mass of 1,485 kilograms. What is its weight on Earth? Whenever a question like this is asked, you always write down what the formula is. That way you will be able to see what is expected of you for the question. So we have Fg is m times g. Mass we've given you there is 1,485 kilograms times g, which is 9.8 meters per second, and the weight of this car is then 14,553 newtons. Our second example is Sammy has a mass of 70 kilograms on Earth. What is her mass on the moon? Now, based on what we've just discussed, mass will always remain the same. So the answer here is 70 kilograms, as the mass of an object is independent of position. What that means is that no matter where an object is measured with regards to its mass, the mass will always be the same. Let's have a look at our third example of calculating weight. You have a watermelon with a mass of 2.5 kilograms. What is its weight on Earth? Now again, first step for calculating weight or gravitational force, you write down the formula. The formula here is Fg is equals to m times g. M represents mass, so mass is 2.5 kilograms times g, which is 9.8 meters per second, and our answer is 24.5 newtons. Now we move on to magnetic force. Magnetic force is the force that occurs between two magnetic objects that exert a force onto one another. Again, this is over a distance because this is a field force or a non-contact force. With regards to magnetic materials, we only have three substances that are classified as ferromagnetic. What ferromagnetic means is that they are able to experience a magnetic force. These three substances are iron, nickel, and cobalt. If we go into detail with the types of magnetic forces that occur, we have two types. Our first one is the force of attraction, which is the pulling force that two objects exert on one another, and this will occur when we have two opposite poles. So we have a north and a south pole. Our second type of magnetic force is the force of repulsion. This is a pushing force that two objects exert on one another, and this occurs when we have two of the same poles, so either a south pole and a south pole, or a north pole and a north pole. Let's have a look at magnetic fields. So, firstly, what a magnetic field is, it's the space near a magnet where an object will experience a magnetic force. This magnetic force can either be attraction or repulsion from the magnet. An example in where we can see a magnetic field is Earth's magnetic field. Earth's magnetic field runs from the North Pole to the South Pole, and it protects the Earth from radioactive particles that are caused by solar winds that are emitted by the sun and that travel to Earth. Some properties to remember with regards to magnetic lines. Firstly, the lines are imaginary that form part of the magnetic field around a magnet or around Earth, which means they cannot be seen. The formation in which the magnetic field or the magnetic lines form around a magnet or around Earth is a 3D formation. The lines that form part of a magnetic field will never cross each other, and the more concentrated the lines are, which means the more they are, the stronger the magnet will be. Last important property to remember is that the magnetic field lines move from a north to a south direction. Here are a few examples of how the magnetic field lines look around a bar magnet. First one here is just a bar magnet with iron filings sprinkled over it. So over here is our south pole and over here is our north pole. And this is how the magnetic field will look around a bar magnet. This is a bar magnet with two unlike poles facing each other. And here, bar magnet again with two like poles facing each other. So as you can see, over here, it is an attraction force, and here is a repulsion force because the poles are like, which means they are the same, and here it is unlike poles, so it's a north and a south pole. Now we move on to our last and final field force or non-contact force, and this is electrostatic forces. An electrostatic force can be defined as a force exerted by two charged objects onto each other over a distance. With regards to electrostatic forces, the creation of an electrostatic force is due to the objects gaining or losing electrons due to the movement of the objects, like friction. Objects that gain electrons during the movement will become negatively charged because electrons have a negative charge, and objects that lose electrons will become the positively charged object as they lose negativity. Objects with like charges will repel each other, and objects with unlike charges will attract each other. So, how do we charge objects? The first method is through friction. Friction is the rubbing of two objects against each other, which allows the electrons to move from one object to another. An example could be rubbing a balloon on your hair, or perhaps a ruler to try pick up small pieces of paper. Our second way in which we charge an object is through conduction. Conduction is when a charged object will touch a neutral object and it will share the electrons that it has with the neutral object. The third way in which a charge can be obtained or created is through polarization. Polarization is when a charged object is brought closer to a neutral object, but the objects do not touch. This means that the one side of the object will become temporarily positively charged and the other side of the object will become negatively charged. As you can see in this diagram, here we have a negatively charged object that gets brought closer to a neutral substance, and the one side becomes temporarily positively charged and the other side temporarily negatively charged. A way in which we are able to see electrostatic forces in nature is through thunderclouds and lightning. So, clouds consist out of water molecules. The movement of the air in the dark cloud will then cause friction between the particles that are found in the cloud. The cloud is positively charged at the top and it's negatively charged at the bottom. But the ground is positively polarized, which means there is a positive charge on ground. So the negative charge from the bottom of the cloud will move down to the ground, and lightning is then the discharge of electricity that's being created in the cloud that moves from the bottom of the cloud to the ground. Thank you for attending my lessons, grade 9s. We'll see you for the next section on electricity.